DeepSpar USB Stabilizer is a hardware device which allows any Windows software to quickly and reliably work with unstable USB storage devices. It is built primarily for USB hard drives, but it will also work with any storage device which can be converted to USB through an adapter. In this video, we will show how it works with a few USB drives and a PCI Express SSD using RStudio and PC3000 data extractor. We begin by connecting a USB drive and powering it on through the control panel. Drive identification parameters are shown in the log. The drive shows up in Windows as a regular mass storage device, so any software can be used to work with it. Despite the drive showing up in disk management, Windows never has direct access to it. Our hardware contains an ARM processor which separately maintains two USB connections, one to the PC and one to the source drive. The PC sends requests to our device, which then communicates with the source drive in a separate instance. If the connection with the source drive is interrupted for any reason, it is automatically re-established. The PC remains unaware of any issues, ensuring that drive instabilities do not cause Windows to crash, hang, or drop the drive. The two key settings which affect read instability handling are the read timeout duration and read timeout reset. Duration specifies how long our device will wait for the drive to respond before issuing the specified reset. If the drive fails to process the reset, it will be automatically repowered. By default, all writes are blocked on the hardware level to stop Windows from making changes to the drive. File system mounting is disabled as well to prevent Windows from unnecessarily stressing the drive and running into issues due to unreadable file system metadata. We just started a basic file system scan with RStudio. In the Sector Map tab, we can see exactly what's happening in real time. Green blocks are sectors which were read successfully, and yellow blocks are sectors which were skipped with reset commands because the timeout duration threshold was reached. The scan took 111 seconds. For comparison, running the same scan without our USB stabilizer takes almost 4 times longer. The large difference is there because Windows does not have the ability to skip past bad sectors and must instead wait for the drive to finish processing them on its own, which wastes time and causes further drive degradation. In addition to speed, there is also a major improvement in stability. If the drive has a serious exception during recovery, Windows may choose to drop it, after which every sector will be returned as bad. This has absolutely nothing to do with the software being used, because it's a Windows issue. With our device, the drive can even be physically disconnected during recovery. It will stay active in Windows because our ARM processor maintains the connection even if the source drive is not there. Reconnecting it allows the recovery to continue as if nothing happened. Next, we will try a different USB drive, this time with PC3000 data extractor. Imaging a section of this drive took about 5 minutes, and 112 sectors were unreadable. For comparison, doing the same image without our device took more than 3 times longer and left behind the same 112 sectors. Just like with RStudio, if the connection to the drive is lost during imaging, all sectors will be returned as bad. Once again, this behavior has nothing to do with the software being used because it's happening due to Windows itself. Our device does work with vendor-specific commands, so tools like PC3000 can work through it to build head maps or repair firmware issues. In some cases, it even allows firmware repair procedures with USB drives to succeed when they would otherwise fail due to Windows dropping the drive in the middle of the repair. Lastly, we will work with one of the newest PCI Express SSDs. These devices are impossible to convert to SATA and can only be converted to USB through an adapter. First, we will connect the adapter directly to the PC and attempt to image the SSD. When these SSDs develop read instability issues, they usually stop responding either right away or shortly after starting imaging, causing Windows to lock up. It's impossible to do anything, and it will be stuck like this indefinitely. With our device, such cases can be easily handled by setting the read timeout reset to repower. This way, whenever the SSD gets stuck on a bad area, it will be automatically repowered by our device, allowing imaging to proceed. While our device is built primarily for USB drives, it can also be used with SATA drives connected through a USB drive bay. In this configuration, it certainly won't process read instabilities as efficiently as well-designed native SATA tools like the PC3000, but it's still capable enough to handle most read instability cases, allowing you to free up a SATA port for difficult jobs. Our device is stable enough even for drives with hundreds of thousands of bad sectors, which take multiple days to image. DeepSpar USB Stabilizer is now available and can be purchased from the page linked in the video description. Thank you for watching.